Now, we will see how to reduce an expression using the Carnot map. In one of the previous videos, you saw that one canonical SOP can be represented in the cardinal form. So, we are provided with a question by using the cardinal form, and then we have to make the Carnot map for that and then reduce it. Okay. We are given with f of ABC is equal to sigma 0, 1, 3, 4. I think you remember this term. Sigma shows canonical sum of products, and these minterms which are written here are the minterms which are having the output 1. Okay, since 3 variables are there, we already saw in the previous video how many squares have to be made. 2 to the power n. The n tells about the number of squares. The n tells about the number of variables in the expression. So 2 to the power 3, we have to make 8 squares to reduce this expression. Okay, so make one Carnot map with the 8 squares. We are taking 0 and 1 to this way, and that is represented by the variable A. B and C are taken for the columns. We are numbering them 0, 0, 0, 1, 1, 1, 1, 0. Once again, remember that gray code. Then we had a certain numbering system, and the reason for the numbering also I told in that video. Due to the presence of the gray code, the numbering will be a different one. So we number it as 0, 1, 3, 2, 4, 5, 7, 6. Okay, now these squares which are represented here, these minterms which are represented are to be filled with the ones. Okay, minterm 0 is filled with 1, minterm 1 is filled with 1, minterm 3 is filled with 1, and minterm 4 is filled with the 1. Now what we have to do? Fill all the other squares with the zeros. It shows that the minterm 0, 1, 3 and 4 are having the output 1. That is why that expression is written, the canonical expression was written in the form of cardinal 1. Okay, now in order to reduce this expression, we have to go for finding out certain octets, quads and pairs. What are octets? Octets means 8 ones or 8 data items are coming in the adjacent way. 8 ones or zeros. In the minterms, we will say 8 ones, and in the max terms, we will say 8 zeros. Okay, now next one is we have to try for quad. It is trying for 4 ones or 4 zeros. Then next one is pair, which tries for 2 ones or 2 zeros. So in this Carnot map, we don't have 4 ones to make a quad in adjacent way. 4 are there totally, but 2 are vertical and 3 are horizontal ones. So what we can do is, we can make a pair like this. These two ones are made into a pair, and these two ones are made with another one pair. Why we made them as the pair? That is the question. Because when we move from the top to bottom, or the left to right, only one variable is getting changed. Now in this one, we did not write those variables. What are they? The 0 represents a bar, we did not write it. This is representing 1. 0, 0 are representing B bar, C bar. We already saw that. This is representing B bar C, this is representing BC, and this is representing BC bar. This you could have written earlier. Okay, now when we write the coordinator of this particular min-time 0 coordinators I am writing A bar, B bar, C bar, and this second one, it is representing A, B bar, C bar. See, when we moved from these two squares, only one variable is getting changed. So, as we saw in the algebraic method, we can write this one as B bar C bar common and A bar plus A bar plus A in the bracket. Okay, B bar C bar is taken common and A bar plus A in the bracket. Okay, now plus, let us see the other side. A bar, then B bar C, next one is A bar BC. What is common in that expression? We can take A bar C as common and within the bracket B bar plus B. Again we saw in the algebraic method A bar plus A is equal to 1. So we will write it as B bar C bar into 1 plus A bar C into B bar plus B is also 1, complementarity law. So we will write it as B bar C bar plus A bar C. This is our final expression. But this method is our algebraic method. Okay, I just showed the reason for changing the value of the expression or dropping one variable from the expression. This is already clear when we have studied in the algebraic method. Okay.